starts from rest at P, travels in a straight line, and then comes to rest at Q, which is 696 distance away from P. So here's P, here's Q. Happy days. Now, 696 meters. The time taken is 66 seconds. T equals 66 for the full thing. The first 10 seconds, it has uniform acceleration A1, then travels at constant speed and is finally brought to rest by uniform deceleration A2, acting for 6 seconds. All right, that's handy to know, isn't it? Because we now know that we have a ratio, don't we? So ratios are good. Okay, so let's do the Flossy time diagram. The tail end is steeper because you get brought to deceleration quicker. Okay, and there we go. Now, 10 seconds, 6 seconds. That tells us the middle section as well, doesn't it? Middle section is going to be, anybody? 50. All right, that's easy money all day long. So the reason why it's easy money is I can just do the area of the triangle plus the area of the rectangle plus the area of the other triangle equals 969. Or sorry, 696. So let's do that. Call it V. So it's going to be a half base times height, which is going to be a half 10 times V plus 50V plus a half 6 times V. Okay, so it's going to be 5V plus 50V plus 3V, and that will get us, anybody? 58V, which is 696. 696 divided by 58, Killian. Go on. Be calculator guy. 12. All right. So that's easy money. Now, the acceleration and deceleration is quite handy. Acceleration is tan x. Deceleration is tan y. So what's tan x, which is A1, is 12 over 10, which is simply 6 over 5. There's your A1 value all day long. Now your A2 value is going to be tan y, which is 12 over 6, which is 2. And that's expected, isn't it, the deceleration to be larger than the acceleration. Is that pretty cool? Okay. Now, okay, so I've successfully done part 1. A1 and A2 are done. If the journey from rest at P to rest at Q had been travelled with no interval of constant speed, was subject to A1 for T1 and subject followed by A2 for T2, show that the time for the full journey is 8√29 seconds. Okay. Can I get rid of the diagram? Can I get rid of it? Thanks. Now, here we go, finally. So, in this case, it's going to take slower to get to my maximum speed. You're going to jam on the brakes. Your deceleration phase is a bit more aggressive, so steeper slope, and you have your 2 triangles, okay? We don't know the V value because it's no speed limit, so we don't know how long it took to get to the peak. Is that all right so far? No idea how long that took to get to the peak. Now it says T1 and T2, fair enough, but we know better than that. We have a better system, so we're going to implement our better system right away. So what's the ratio of acceleration to deceleration here? 6 over 5 is to 2. Give a common factor of 5. So what do you reckon? 6 is to 10, or 6 over 5 is to 10 over 5, which is a ratio of 6 is to 10. And the ratio of 6 is to 10 is the same as what? 3 is to 5. All right, so what's my trick that I've sort of been trying to beat into you this year? What should I change T1 into? 5T. What can I change T2 into? Yeah, no worries, 3T. Is that okay with you guys? 5T and 3T. Okay, 5T and 3T. Is there any other information I have? I know the total distance, don't I? So I can use 2 triangles or 1 triangle, it's all the same, so I'll just use the 2 triangles. A half base times height plus a half base times height. And what does that equal? What does it equal? Sorry? 696 has to equal that because it's the area of the graph equals the distance travelled. So what's that? 5 over 2 VT plus 3 over 2 VT, which will equal 8 over 2 VT, which would be 4 VT. 4 VT is 696. Can you divide 696 by 4 for me? Sorry, 1. You're saying 200? It can't be 200. Sorry, my fault. Yeah, go again. There we go. All right, 174. Now, you'll notice 2 variables, 1 equation isn't going to cut the mustard for me at all, all right? So here's my second suggestion. You can either use deceleration or acceleration, it doesn't matter. I always use acceleration for some reason. I have no idea why. What can I say tan x is equal to? Tan x equals phi over 5t. Would you agree with that? The next thing is phi over 5t is the same as what? The acceleration, which is what number? 6 over 5, yeah? Now the 5s are going to cancel. So what would that leave then? The 5s cancel on the bottom. So it's going to leave phi equals 6t. That suits me right down to the ground now. So what can I do with this equation over here? Yeah, exactly. It's going to be 6t times t, which is 6t squared. And 6t squared equals 174. Can you divide it by 6 for me? And square root the answer, root 29. Yeah. Now, some of you will be saying, that's not what it wants. It wants it to be 8 root 29. But count across, how many t's do I have from start to finish? From here to here? It's your 5t plus your 3t, which is 8t, which is 8 times root 29. And you're done. So, driver of a car traveling 20 meters per second sees a second car 120 meters in front. So, car A, car B, 120 meters gap at the beginning. Same direction with uniform speed. So, if it's traveling in the same direction, this means that B isn't accelerating. So B is essentially stuck at a U value of 8 and a V value of 8 and an A value of 0. Okay, so that's set in stone. Now, I'm traveling at 20, A is traveling at 20. No mention of an acceleration, is there? Ah, never mind. You want to decelerate so you don't hit the faster car. Everybody cool with that? So you start off at 20, you have a deceleration, which is the goal of the question. So we just highlight this here. I need this to answer the question properly. What does my v value have to be to avoid a collision? Just has to be 8, doesn't it? Just have to match. So I literally come up to the back of the car, or technically the same point. You assume that in applied maths, you assume that if you stop where the car is, there's not a collision. I know that's not always the case, but that's what you assume in applied maths, okay? Otherwise, it just becomes ridiculous. So what we're going to assume is that our phi value is 8, okay? What is the distance difference? How much extra distance do you have to play with? If B was to travel, for argument's sake, if B traveled 60 meters, how far would A have traveled to make up the difference and just be right at the same level as B? A would have traveled 180 because it'd be your 60 plus your 120, which would have given it 180. Now, we're not subject to knowing how far B went. So for argument's sake, I'm going to call the distance for B x. So what does that mean for the distance of A? X plus 1, 20. Is that cool, you guys? Does the question start at the same time? Does anybody have a like, is one of them delayed, or are they both moving at the same time? So that means we can use the same t value. Time is the same. Alrighty. Now, one of the more interesting ones. If I use s equals ut plus a half at squared, I'm going to end up with 3 variables. I'm going to end up with the x, I'm going to end up with the a, and I'm going to end up with the t. If I use phi squared equals u squared plus 2as, I end up with 2 variables. So, like, this one's interesting, right? Because you might have to use 3 equations and put it all together at the end. I think we could start off with the easy ones first. Maybe we start off with phi equals u plus at for the data set A. It's an easy equation, and it might give us something useful to work with in a minute's time. So what's the v value? 8. The u value is 20. And then at is just at. That's easy money. Minus 12 equals at. The goal is it wants acceleration. So should I get t in terms of a or a in terms of t? T in terms of a or a in terms of t? T in terms of a, and I'll tell you why. When you're going to substitute out t and you're going to leave in a, because that's what the question is looking for. It's looking for the deceleration. If it was looking for the time, I'd definitely do a in terms of t. So that's thinking ahead, right? You don't have to think that far ahead. You can always just fix it at the end. Well, I'm quite lazy. I don't like doing extra work, so I'm going to do it this way. So t equals minus 12 over a. All right, that was a good formula to do. Now, let's try my beloved s equals ut plus a half at squared. Now, I know I'm going to have to use that. Why am I going to have to use the s values? Because that's how the equations link to each other. One of them is 120 meters longer than the other one. That's how the equations actually link together, okay? That's no bother. So, let's do that. If I'm in an exam, I want to get the easy money first. Which one's the easy money? Data set B or data set A? B is the easy stuff, okay? So I'm going to go for x equals u, which is 8 times t, which is t plus a half. No acceleration, t squared. I'm just going to say x equals at. Could be worth 5 marks instead of spending ages on the other one. Okay. Next one. We're going to get, we're looking at x, which is x plus 120 for s. And once again, we're doing ut plus a half at squared. In this case, your starting velocity is 20. t plus a half a exists and t also exists. Now, getting there. Have two substitutions to make this quite easy. Here and here. What should I replace them with? X gets replaced with AT. The A gets replaced with minus 12 over, oh sorry, not the A, my fault, not the A, the T gets replaced. So it's A times squared, yeah? All right, let's do this. Oh no, I'm such an idiot. I'm such an idiot. That's still two variables, isn't it? Quick switch. Go back to my original plan. Let's get rid of A. So what are we going to do instead? Just jimmy this around. Sorry, my fault. Sometimes they just materialize differently. A equals minus 12 over T. My fault. So what do we put in here? Minus 12 over T and then T squared on top. All right, now I'm in business. Thinking too much. Now, 20T. That's 144. Sorry, no, it's not. It's cancel that T with that T. Half it, and we get minus 6T. Is that right? We're going to get 14T, take away 8T, because that 8T is going to move over to the other side, become another 8T. So it's going to be 6T equals 120. We're going to get a T value of 20 seconds. We're then going to lob that into the A value. So we get minus 12 over 20, which is minus 3 over 5 ms2. All right. You have an A value of minus 1. This means you actually have more deceleration than you need, which means you're not going to reach the car, you're going to stop short of the car. So our job is to figure out what happens in that type of scenario. So all this work I've just done here doesn't matter anymore. So this is all gone. All we know is it's going to fall short. Now that's gone. Our A value we do know. A value is now minus 1. T value remains the same. Now, it's no longer X plus 120. We want to be 66 meters behind the slower car. What's 120 take away 66? 54, hopefully. Is that okay? You guys 54 meters? Okay. Now, in this 54 meters, what I'm going to say here is that A has to travel 54 meters further than B. Would everybody agree with that? To bring us 66 meters behind, A has to travel 54 meters longer. So I'm going to change this to what? X and X plus 54. Okay. So we're pretty much doing the same thing. What's false about this data set? E8. Or is it? Find the time interval in seconds for the car to reach a point 66 meters behind the slower. It doesn't say it has to be on the same speed, does it? Just says that you got to reach 66 meters behind the other car. You might be going faster. You could be going something like 12. You're 66 meters behind the other car, but yet you're still catching afterwards, aren't you? So that could happen. So you don't know the V value. V value doesn't exist at the moment, okay? So, looking for us, UT plus a half AT squared completely bypasses the V values. So I think we should be in business using ut plus a half at squared. We don't need the v values to make this work. Okay, so confident I left it here. Now, let's go for the easy money again. X equals ut, which is at plus a half times 0t squared. X equals at again. Could have left that there from the last question. Let's go for s equals ut plus half at squared again. X plus 45 plus 54 this time is 20t plus a half a, which is minus 1, and t squared. So it's going to be 20t minus a half t squared. X plus 54. Once again, replace the x with at. So we're going to end up with at plus 54 equals 20t minus a half t squared. Move it all around. Oh, sorry, multiply by 2. Don't want to deal with a fraction today. 40t minus t squared. Get it all in line. T squared. 16 take away 40 is minus 24t plus 108. Factors of 108 are, I think 6 and 18 will do the trick nicely. So t minus 6, t minus 18 equal to 0. T equals 6 or t equals 18. That cue you guys? Which one is it? 6 or 18? Why is there two answers? Physically speaking, why is there two answers? Yes. Yeah, A's in the lead, isn't it? So A is here, B is here. B is currently moving faster than A. So exactly what Oscar says. B gets closer to A. Then it gets even closer to A, but then what happens? Stops moving. Then A pulls away from B. And then once again, you're going to hit the 66 mark again, aren't you? So which is the answer I'm looking for? The first or the second? First answer. Okay. The shortest distance between the two cars. Now this one's. When does A start pulling away from B again? When B's phi value goes below 8. Because remember, A is moving away. So when B's phi value goes below 8. So in this case, we get to set phi equal to 8. All right, all this stuff is gone now. I haven't got a clue how to relate the x values this time. But what can I find out straight away though? I have enough info. I have u, v, a, one variable left, t. How can I find out the time? V equals u plus at. 8 equals 20 minus 1t minus 12 equals minus t. T equals 12. That makes sense, doesn't it? Because our last answer was 8, t equals 6 and t equals 18. So obviously the car stopped moving somewhere. Obviously the car reached its minimum point somewhere en route here. Okay? So its closest point is t equals 12. And then after t equals 12, A starts to pull away from B, and 6 seconds later, it was 66 meters away again. So that makes complete sense. Okay. Now, if we know that, then I can obviously find out how far B traveled. How far did B travel? Distance multiplied by time. 8 multiplied by 12. Anybody? 96. So this lad travelled 96 metres longer. It had a 120 metre head start. It travelled an extra 96 metres. Next thing I need to do is find out how far A travelled. So you can take your pick. I'll use UT plus half AT squared again, the usual. So what we'll go here is UT plus half AT squared. So S equals UT plus a half AT squared. S equals 20 times 12 plus a half minus 1 times 12 squared. Anybody got the answer for this? That'd be good. Save me a bit of time. 240 take away 72. 168. Is it 168? Somebody just double check that for me. Yeah. How many meters did it gain? 168 take away 96. How many extra meters did you gain? 72. You gained 72 meters. However, you had a 120 meter head start. So 120 take away 72. 48. Who got 48 meters? It's the shortest distance between the two cars. No one. Is that the answer in the back? Actually, we don't know. Somebody's don't have to look. All right, let's just say I'm right.